Alright, here we go. Welcome to Math 8, Unit 3, Lesson 14, using linear relations to solve problems. We're going to write some equations for real-world situations today and think about their solutions. So the first section here, we're talking about buying some fruit. Alright, we're going to write an equation to represent what's going on in the story. It says that grapes cost $2.39 a pound. Alright, so think about this. G for grapes. Grapes are going to be $2.39 for every pound that I buy. If I bought 0 grapes, then I could plug a 0 in there and it costs me no money whatsoever, right? $2.39 a pound. Plus, bananas cost 59 cents per pound. So I put bananas here as 59 cents and I multiply it by B for how many bananas I might purchase. And it says that I have $15 to spend, so my total is going to be equal to $15 in total, right? So my equation for this is going to be the rate for how much it costs per grapes per pound and time plus the bananas per pound equals my total amount of money that I can spend. Okay, if I took the dollar signs off, I would have 2.39 in G plus 0.59 B equals 15. And with that, I'd be able to figure out what I might be able to do, right? If I bought 2 pounds of grapes, I could put 2 in there and multiply it out and see what I have left for bananas, whatever it might be. All right, number 2. A savings account has $50 in it at the start of the year. So we know we're starting with $50 in our account, and $20 is deposited. Well, what is a deposit? A deposit means I am adding to something I already have. Okay, is deposited each week. So each week we're doing $20 again and again. So we can call that X. It says X weeks here. After X weeks, there are Y dollars in the account. So I start with 50 and I add $20 every week. At the end, I'm left with some kind of amount of money there. I might not leave it written like that. That's just kind of how the story flowed. You might want to rewrite that as Y equals 20X plus 50. That gets it more in the form that we're used to. That's that Y equals MX plus B, right? Where we're talking about our rate and we're talking about our y-intercept, where that starts at, right? So if you graph that out, you would say it starts here at 50, and then we're going to be going at a rate of 20 to 1 all the way up for that savings account there. Okay, so I had another point there. I might say this is 70, and that would be 1, something like that. Okay, let's take a look at the next page. The next activity was about 5 different savings accounts. And with these 5 savings accounts, it says that each line, coming in focus there, that each line represents one person's weekly savings account balance from the start of the year. So these are 5 different people and how they save their money. All right, we have A, H, C, D, and E. It says to choose one line and write a description of what happens to that person's account over the first 17 weeks of the year. Do not tell your group which line you chose. All right, so if I was to say, for example, that I had a friend, his name was John, okay, and John had $80 at the start of the year, okay, but after 8 weeks he was broke and had to borrow money or went in debt, then there we go. I could take a look and say, well, who could that be talking about? Who started at $80 at the start of the year, but after 8 weeks found out that he was out of money, had to borrow more money, and went into debt? Well, to find out that person, I might say, well, they said they started at $80 at the beginning of the year, so who started at 80? Well, that's going to be this guy here. Does that seem to decrease if he's spending money? Well, he sure is spending money quickly. And where does he run out? Oh, he ran out right here at 8 weeks. That matches my story. And sure enough, he maybe had to borrow money or went in debt because he just kept spending even though he doesn't have any. He's going to have a terrible bill later on in life. So don't do that. Don't be like E, line E. So we would say line E describes my story there. You can do that same thing for the other charts here, other graphs here, and make up your own story. Okay, and see if your partner can guess your story or guess which line you're talking about there. The next one, number 3, says to write an equation for each line on the graph. What do the slope m and vertical intercept b and each equation mean in the situation? So let's go ahead and write these out. We have lines A, we have a C, we have a D, we have an E, and we have an H. So looking at A first of all, okay, we can write them on here if we chose to. So A, we're going to start with y equals, now our slope for this one, it looks like we're looking at points here. I have a point that goes up from 50 to 70, so we're going up 20, right? We're going up 20, and then we're going over, this is 1. So our slope for here seems to look like a 20 over 1, because of just how we're going 20 to 1, we're going 10, 21, 10, 21. So we would say our slope is 20, and that's our x, and our y-intercept value is going to be here at 50. So we have A, the value of the equation for line A is y equals 20x plus 50. For H, let's look at H now. It's right here. We would say that y is equal to, well, what's the slope in this case? We're going from point to point. We're also going up 20 and over 1, 20 and 1. So we have the same slope, 20x. The difference though is that our y-intercept here is at negative 80. So we would write down 20x minus 80 for where that one is going to start at there. Okay, so that's how we do H there, no problem. Let's take a look at C. All right, so here's C. For C, we would say y equals, in this case, we can tell we're going down. We're going to have a negative slope. So let's see what's happening from point to point. I have a point right there on my equation, and I'm looking for where it crosses another line at. There's one right there. So I'm crossing there. So how much am I going down? I'm going from 110 to 90. 110 to 90, so I'm decreasing by 20 again, but instead of increasing, sorry, I'm decreasing by 20. So we would say it's minus 20 so far, but notice that we're going down 20, but over 1, 2, 3, 4, 5. Negative 20 over 5. Can I rewrite negative 20 over 5? Sure I can. That can reduce to negative 4. So the slope for this one would actually be negative 4x. And we take a look at where we started. We started at 110. And so we would say plus 110 for C, or that's going to be at there. All right, let's take a look at D. So for D, y is going to be equal to, well, do we have a slope? Are we going up 1, over 1, down 1? We don't have any slope, do we? There's no slope, so there's no x value at all. Okay, remember that. No slope means x equals 0. So there's no slope happening there. So what is my intercept point? My intercept point happens to be at 30. So this is just a line that says y equals 30, going straight across there like so. So this person here started with $30 in the bank and didn't do anything with it for those weeks, just left it there, nothing going on. Now let's look at our last one, E, which is also a decrease, right? So we take a look at this person here, and we know we have y equals, let's see what the slope is going to be here. We can see that they're starting at 80, and we're going down 1 over 1. Really, it's down 10 over 1, down 10 over 1. So their slope's going to be negative 10x, and our starting point, our y-intercept, is going to be at 80. So negative 10x plus 80 for line E is what we would say for that one there. Okay? So for which, number 4, question 4 on the next page says, for which equation is 1 comma 70 a solution? All right, so we need to find 1 comma 70. 170 is going to be right here at this point, right there. So if I was to highlight it in some way, there's 170 is located right there. So for what is that a solution? It's a solution for which line? It's a solution for line A and a solution for line E. That's where it matches there. We could say line A and line E. Predict the balance in each account after 20 weeks. Okay, so to predict the balance in each account after 20 weeks, what I can use is I can use my equation to put that value in there. Okay, so let's write this out real quick. Here's A. Our equation for A was 20x plus 50. That's my equation for A. So I plug 20 in there, it's 20 times 20 plus 50. 20 times 20 is 400. 400 plus 50 is 450. That's my answer for A. For B, or sorry, not B, what's our next one going to be? C, sorry. So for C, our equation was, where'd C go? Negative 4x plus 110. Plug in 20 in there, negative 4 times 20 plus 110. Negative 4 plus times 20 is negative 80 plus 110 is going to equal $30. So C is going to have $30 after 20 weeks. Okay, looking at D. D has y equals 30. It's just going to be 30. Nothing changes with D. That's all there is to it. For E, E has an equation of y equals negative 10x plus 80. So we do negative 10 times 20 plus 80. This becomes negative 200 plus 80. Negative 200 plus 80 is going to be negative $120 is where we are for that one. And finally our last one is H. The equation for H is 20x minus 80. So we do 20 times 20 minus 80 is 400 minus 80, which is 320 for H. So we just have to use the equations that we came up with before and plug the value 20 into the X spot there. Okay, let's move on to the next section here. Fabulous fish. The Fabulous Fish Market orders tilapia, which costs $3 per pound, and salmon, which costs $5 per pound. The market budgets $210 to spend on this order each day. All right, so in terms of an equation, what an equation would look like here, right? We can say that it's going to be $3 for the tilapia plus the $5 for salmon per pound is going to equal the $210 that I can spend. So that's what our value is going to be there for. That's our equation. So in terms of combinations that I could use for how this might work out, okay, I can just kind of guess some numbers and figure that out there. But I want to end up with 210. I want to end up with an actual solution here as well. So let's do some zero solutions first of all. Let's pretend that I don't order any of the tilapia. Okay, so I order 0. So 3 times 0 plus 5s is going to equal 210. So that would be 5s equals 210, and 210 divided by 5. 210 divided by 5 is going to be 70. So one thing I could order would be, in terms of my tilapia and my salmon, I could order none and get 70 of those. That's an option. I could also go the other way, and we could do 3 times the tilapia equals 5 times 0, and that plus 5 times 0 equals 210. In this case here, I'm left with 3t equals 210. So tilapia is going to equal, in that case there, would equal 70. I think I did something a little off there. Yeah, I did. Sorry, back it up here. Looked at my wrong little sheet of paper. Let's back that up, back that up. So sorry, back it up, back it up, back it up. 210 divided by 5 is 42. Sorry. And then this one here is 70 there. So when I order no salmon, I can get 70 pounds of tilapia. Okay, so there's 2 solutions right there so far. Right, looking good. Now, in terms of other numbers I could use, there are probably lots of other numbers I could use to figure this out, but I want to get an actual solution here. So those numbers work out well for me. I went ahead and I said, let's just do 2 and see what I get. Okay. Now, I guess the question is that I'm not sure about is, do I need to spend all $210? If I need to spend all $210, then I need an even answer. If I don't have to spend $210, I don't need an even answer. But let's go ahead and pretend like we do for now. If I did 3 times 10 pounds of the tilapia plus 5s equals 210. This would give me 30 plus 5s equals 210. And then I would subtract 30, so 5s equals 180. And when I divide by 5, s equals 36. So if I was to buy 10 pounds of this, I would end up with 36 pounds of the salmon. Okay, so there are ways to kind of go about that there. I could do some other numbers and figure that out. If I did, for example, 50, let's do 50. I'm doing some whole numbers with this so I can end up dividing by 5. If I did 3 times 50 plus 5s equals 210, I would get 350 plus 5s equals 210. Yep, 210. And then if I subtract, well, that's not going to work. I might end up with a negative number, aren't I? Let's not do that one. That's too big. Well, that's too big. So ignore that one, don't do that one there. So there's 3 so far. Can I get 2 more? Probably can. I'm going to stop right there just for time. All right, so define variables, write an equation. We did that at the top already. We said 3 times tilapia plus 5 times the salmon is going to equal 210. That would help them know what they could order. If I was to sketch this out, which is number 3, next question is to sketch it out there. Okay, we'd sketch this out like so, and I could say that, in this case here, I could say that my salmon is on this side, and my tilapia is over here. And with the points that I have, I know that when tilapia is 0, my salmon is at 42. And I know that when my salmon is at 0, my tilapia is at 70. Right, so at that point there. And I also know that when my tilapia is at 10, which might be about here, my salmon is at 36. 36, okay? So it would look something like this. 10, 36 is there. My graph would look something like that. Those are my options when it comes to graphing that. Which means there are other points along this line that would be solutions to that equation. On your plot, on your graph, plot and label the combinations A through F. Okay, so what it's wanting me to do is to use my little graph here, my chart here, and figure out where these might be at. Where would those be? To do that there, what I'd have to do is I'd have to kind of say, well, if 5 is here and 36 would then be here, that's where A is going to be at, a little bit off the grid there. If 19 is here, where's 30 going to be? It might be on there. So the idea is if I had a nicer graph, which I don't have, I would want to plot these points in there, and I'd get some that would be off, some that would be on, and what we want to do is to say which of these combinations can the market order, which means which one's going to be on the line. That's the question they're asking here more than anything else. So plotting the points will just show you that they're scattered about there or on the line, which you could see visually, or I can plug them in. So let's take a look at a couple of these. If I looked at A first of all, knowing that my equation is still 3t plus 5s equals 210. Okay, that's my equation. Let's take a look then. If I have 5 for the tilapia, that would be 3 times 5 plus, and then I have 5 times 36. And when I multiply that out, I end up with a lot of numbers. I end up with 15 plus, and then my 5 times 36 is equal to 180. And 180 plus 15 is equal to 195. So does that equal 210? We would say nope, it doesn't equal 210. So in this case here, I'm not using my full budget. We would say A is not going to work out there, okay? Because they want it to be equal, or to actually match the 210 number. That's the goal. So for B, we would say, all right, 3 times 19 plus 30.6 times the 5, and we multiply those things out. 3 times 19 equals 57 plus 30.6 times 5 equals 153. When I add those two things together, I end up with 210. So B would work. Okay? And again, that's what you're going to do as you go through this here, is you just try each one of those. You plug in this for your value for t and s, and your question is does it equal 210? If it equals 210, then we would say, yep, it's going to be a combination they can order. If it doesn't, we would say no, and we can cross that out like so. I'll tell you as you look at your next 4, and you could always pause the video here and do the next 4. When you look at the next 4, 1 out of the 4 is going to be a solution. Okay, so 3 of them won't work, 1 of them will, if I did my math right, which sometimes I don't. All right, list 2 ways you can tell if a pair of numbers is a solution to the equation. 2 ways. We could look at the graph and ask ourselves, is it on the line of the graph? And the other way we could kind of check it there is we could make an equation, okay, and we can like do the math basically. All right, we could plug that number in to see if it's going to work there. All right. Anyways, just a couple ideas. Let's take a look at tonight's homework, and we'll do our last one for this unit. All right, so here we go. Homework for lesson 14. The owner of a new restaurant is ordering tables and chairs. He wants to have only tables for 2 and tables for 4. The total number of people that can be seated in the restaurant is 120. Okay, so let's see what we can do here. First thing I'm gonna look at is that problem. My tables for 2 we'll call x, and my tables for 4 we'll call y. So what we can have is we can have 2 times x, because that's 2 people for that table, plus 4 times the number of y tables for 4 is going to equal 120. Okay, this right here is just how I started. It's actually the part B question, to write an equation represent that situation. Just for me, I like to start with that equation if I can, because I think it's just kind of where we're after anyways. Describe some possible combinations of 2-seat tables and 4-seat tables that will seat 120 customers, and explain how you found them. All right, so again, like we've done before, let's pretend that I have no 2-seat customers. If that's 0, then I have 5y equals 120, and y is going to equal 30. So I could have 30 4-seat tables, that could work, and no 2-seaters. I could also do no 4-seat tables, which would then give me 2x equals 120. That would give me 60 2-seat tables. So I kind of have an idea of where I'm at there, right? I'm going to be anywhere from 0, 30 to 60, 0. Those are my options as I look at those things there. Okay, I could do some other ones as well. I could plot some. I could say, well, what if I had 10 2-seaters? Okay, what would that be? Well, 4y equals 120. This is going to be 20 plus 4y equals 120. Subtract the 4y, or subtract the 20, and 4y equals 100. So y is going to equal 25. So another point I could have is 10, 25. For one more little point there, what I could look at is I could say, let's do a 40. If I did 40 of the 2-seaters, 2 times 40 plus 4y equals 120. This becomes 80 plus 4y equals 120. Subtract 80, so 4y equals 40, and y equals 10. So another option I could have is I could have 40 2-seaters and 10 4-seaters. Okay, so it gave me some options here. Here's 1, 2, 3, 4. That's my equation. To graph this here, we would do something like this. Okay, and we can say this is our 2-seaters here. Here's our 4-seaters there. For my 2-seaters, I know I'm going from 0 to 60, so I can graph that out and say 10, 20, 30, 40, 50, 60. All right, all the way out there. And for my 4-seaters, I'm going from 0 all the way up to 30. So again, I could go up by 5. So 1 and 2, 5, 10, 15, 20, 25, and 30. And I plot those points. I have 0, 30 here. 60, 0 there. I did a 10, 25, so about there. And I also did a 10, 20, 30, 40, 10 about there. Right? So that's what my graph would look like for those 4 points. If I drew my line, I should have a straight line. It's not perfect, I know, I'm just sketching it out. But I have a line that would go somewhere around there. So these would all be solutions as well on that line. So what does this slope tell us about the situation? Okay. It tells me that when I have the more two seats I have, so the more two-person tables I have, the less four-person tables I'm going to have. So every time I add a two-person table, I'm decreasing the number of four-person tables I'm going to have. Okay? Now the slope for this equation, if I look at the slope, let's look at these points here, the 0, 30 ones there. My slope's going to be the difference, right? 30 minus 0 over 0 minus 60. Okay, that becomes 30 over negative 60, which is negative 1 over 2. So every time I'm decreasing every time I'm going down a four-seater, I'm adding two two-seaters, right? So when I remove one four-person table is going to mean adding two two-seaters, however you want to think about that. Okay, that's what the slope tells me there. Interpret the x and y intercepts as the equation. That's telling me if I only have the two-seaters or the four-seaters. If I only want to do four-person tables, then I'm going to have 30 of them. If I only wanted to do two-person tables, I could have 60 of them there. All right, next one, number 2. Triangle A is an isosceles triangle with two angles of measurements x degrees, x, and one angle of measurement y degrees. Find three combinations of x and y that make this sentence true. So again, I like to start with my equation. So I'm going to go with 2x plus 1y is going to equal something. It's a triangle. The measurement of the angle of a triangle is always going to be 180. So we're going to start there for my equation. So what could work? Well, some options that could work here. If x equals, and which is some nice whole numbers here, if x is equal to 60, and I did 60 because I like how 60 works with 18, or 6 works with 18. If that's true, we would have 2 times 60 plus y equals 180, and that's going to be 120. We subtract the 120 over here, and so y equals 60. Now in that case there, that's going to be an equilateral triangle. So is that really a solution? Not quite, because it's equilateral. You may not want to do that one as a solution. It would work, but it's not isosceles. Okay, so let's try 30. If x is 30, then what do I get? I do 2 times 30 plus y equals 180. This becomes 60. Subtract 60, and we have y equals 120. So I could have a 30 and a 30 and a 120 for the angle measurements of an isosceles triangle that could work. That could work there. Okay. I could also try a 40. If x equals 40, what would I get? Well, I'd have 2 times 40 plus y equals 180. That becomes 80. Subtract it from there, and y equals 100. So I could use a 40 to come up with that one there. So there's a couple options there for you. I'll let you come up with one additional one for your homework there. So I think 2 out of 3 is pretty good help. Now let's take a look at our last page here. Write an equation, which we already did. We said it was 2x plus y equals 180. Makes the most sense there. If you were to sketch the graph of this linear equation, what would its slope be? How can you interpret the slope in the context of a triangle? Okay, now for our slope here, we would say the slope would be negative. Okay, it's going to be going down because if I move things around, I have 2x plus y equals 180. I subtract 2x to move to the other side, so y equals negative 2x plus 180. Okay, so my slope's going to be negative. And so what's happening there is that every time I'm decreasing this by 2, I'm also going to move over to 1 to the right as well. So it's a 2 degree decrease of y. So that means that this means that a 1 degree increase of x is a 2 degree decrease of y. Okay, so that's what that's going to mean there. Every time I increase x by 1, I decrease y by 2. All right, moving on. Number 3. Select all the equations for which -6, -1 is a solution, which means I need to plug that number into each one of those there to see if it works. So we have 4 times -6 plus 23. That becomes -24 plus 23, which becomes equal to -1. Does it work? Yes, it does. Next one, B. We're going to do 3 times -6 equals 1/2 y. 3 times -6 is -18. We're going to multiply by the reciprocal, which instead of a half is a 2. That's going to equal -36. Does that match that? Nope, it's not there. We would say no. The next one, we're going to do 2 times -6, and I can just plug it in. I can say -13 times -1. Does that equal 1 is the question mark there. So I just plug both values in. I can do that. So -12 minus 13 minus 1 becomes plus 13. Okay, so -12 plus 13 equals 1. Does 1 equal 1 in this case here? Because I put it already in, we would say yes. So C is going to work there. This next one, 3 times y, we could do 3. I could leave the y there if I chose to, equals 1/2 times a -6. This becomes 3y equals -6 times a half is -3. Divide both sides by 3, and y equals -1. Does that match there? It sure does, and we have another solution for that one. And our last one here, we have 2x. Let's do 2 times -6 plus 6y equals -6. So we have -12 plus 6y equals -6. Add 12 to both sides. So 6y equals 6. Divide by 6. Y equals 1. That's a great answer, but it doesn't match that, so we would say no. And our last one, consider the following graphs of linear equations. Decide which has a positive slope and which has a negative slope. Then calculate each line's exact slope. All right, so L is going up. We would say this is positive. M is going down. We would say that's going to be negative. In terms of the exact slope, we take a look at some points here. So here's a point at 80 and there. So for this one, we do 80 minus 20 over 8 minus 5. That becomes 60 over 3, which becomes 20 for the slope of line L. Over here, we have a -40 minus 20 over 8 minus 5. -40 minus 20, 8 minus 5. This becomes a -60 over 3, which becomes a -20. So the slope of this one is -20. Slope of that one is +20. And that's what we have for that. Hope that helps you out. Good luck. You should have a test coming up on this unit. Have a great day.